Cool. Monitoring several chats at one time. So it's good. I'm getting live feedback. You guys can heckle me in real time. Uh, cool. All right. So we have one more minute just in case anybody hops on, and then I will start my talk. Might go over, might go under, but we'll see how it goes. I'm really happy that you guys all came today. Like Sam said, like this conference, this idea was just something that I was inspired to do. Actually, by if any of you went to the Walmart virtual security meetup they did, their security team, which I know a couple guys over there, are super elite, and they did one very similar to this. It was much smaller, um, and uh, and I was just like, man, let's just do that. That sounds awesome. Yes, I did say Walmart. Yes. So yeah, and I just went to Sam. I'm like, Sam, we need to set this up and just do it. Yeah, it's been a total success. I'm really excited to learn from everybody today. I got the opportunity to do the CFP review and review the slides and just kind of see who was coming on and submitting, and super humbled by the amount of interest, the amount of submissions we got, the people that submitted, and then the content of the slides themselves. They're all over the place. The topics are great. They're spread out across different types of testing, different skill sets, and I think there's a lot for everybody to learn today. So cool. Well, it's 10:26, and I will get started. Let's see here. Controls work. Yes, they do. All right. So if any of you don't know who I am, my name is Jason. That's me on the upper right-hand side there with my son. We decided to wear matching T-Rex shirts that day. So I do some hacking here at Bugcrowd. I'm also the head of trust and security, but I do a little bit of everything around here. I was a bug hunter on Bugcrowd in 2014 and 15. I was the top spot for about 8 months to a year, I think, and I'm top 50 currently. I'm also a dad first, a hacker, a blogger, and a gamer. And if you guys play games, those are the games I play referenced below. Would love to hang out and just chill. So what is this talk about? So this talk is called the Bug Hunters Methodology 2.0, and it's a follow-up talk to one I did 2 years ago at DEF CON 23, and then gave a couple times after that, which was called How to Shot Web, or what was the other name? It was How to Shot Web or the Bug Hunters Methodology, right? There was a couple names for it, but it was the same talk. And it basically had what I had parsed from the community the last couple of years in blog posts, in disclosure notices, monitoring chat, asking people about what kind of tooling they were using, what kind of bugs they were finding, what stuff was basically relevant to bug bounty hunting, and then converting it into a presentation that could help level up a lot of new people. So the talk is about hacking stuff better and practically. So the last one, the Bug Hunters Methodology, the How to Shot Web of DEF CON 23, had a lot of stuff in it. So I focused on the philosophy shift from pen test to bug bounty. I focused on discovery and mapping, parameters often attacked, useful fuzz strings, filter evasion, memes, and then all that filtered into a couple of vulnerability classes. So subdomain finding, SQL injection, cross-site scripting, file uploads, CSRF, privilege auth, and IDOR bugs. So we're actually not going to talk about anything that we talked about in version 1. So if you haven't seen version 1, this is a direct sequel. You're missing out on a ton of context. I try to talk a little bit about it, but really we're moving forward to advents in the last couple of years since this talk has been given. So you can click, or you can Google, actually I don't think you can click over Zoom, but you can Google the Bug Hunters Methodology or How to Shot Web and see that video later and kind of check out the previous research. So version 2, more discovery, more XSS stuff, SSTI, server-side template injection, server-side request forgery, code injection, command injection, some advancements in fuzzing, tooling to go around all this kind of stuff, some ideas and kind of basis and overview of our infrastructure and configuration vulnerabilities. And then I wanted to get to you guys API testing, object deserialization, and XXE, but I just didn't have enough time before this presentation, so that'll be out in V2.5 of whatever this presentation looks like. All right, so the first part of the last presentation in the Bug Hunters Methodology 1 was an introduction and to say that the Web Application Hackers Handbook and the OWASP Testing Guide were the two primary resources for anyone new who's getting into this that they should probably go over, right? There are a lot of resources. There are a lot of blogs that you can follow, but those two print resources will help you get started in understanding hacking web apps. Now, since I gave the last talk, there have been 3 new additions to kind of the list I recommend reading. So one is Peter Jaworski's Web Hacking 101, which goes over, Peter does a great job of kind of wrapping introductions to vulnerabilities and then citing to public disclosures of vulnerabilities and showing you how they really manifested in actual web applications. Then we have Breaking into Security by Andy Gill and Mastering Modern Web Penetration Testing by Prakhar Prasad. Those are both really good. One's a soft skills book and then one's a technical book, and they have some of the information in my slides, but really it's a little bit of light reading. If you can go front to back with the Web Application Hackers Handbook, the OWASP Testing Guide, and those 3 new resources, you're on a really good start towards application security testing if you're new. All right, so the first section of this talk is about discovery, and discovery is my favorite thing. Probably like actually more hyped about discovery than anything else. I mean, I do enjoy hacking sites and getting paid, but I just geek out over discovery because I like finding things that people haven't found before. So if you go into kind of the discovery world and what we talked about previously in the Bug Hunters Methodology 1, we talked about scraping for subdomains. We talked about a tool and how we do this called enum all, which is a wrapper around ReconNG, the framework for OSINT information gathering, and alt DNS, which is a permutation scanner that looks for subdomains. So ReconNG and enum all, and the ideas there were to scrape Google and search engines and all kinds of stuff to pull back subdomains that you could add to your scope, right? I mean, the idea behind this is to not only be able to hack the main site, but if it's in scope, go after stuff that's unknown. And then we covered Nmap standard and stuff like that, like how to not forget the port scan stuff. In the new version, we're going to talk about more sub scraping, sub brooding, and port scanning. So we'll go right into it. So this is Sublister. So Sublister is kind of one of the new defaults for everybody doing subdomain scraping. So it scrapes Baidu, Yahoo, Bing, Google. Here we're running it on a sample of Tesla. They have an open scope bug bounty, so nothing wrong with this. So you can see the output of it scrapes all of these search engines and public sources for any time that Tesla's mentioned. And it's really good. I like Sublister a lot. In fact, I would say I enjoy Sublister more than the wrapper I wrote around ReconNG for multiple reasons. The problem lies when you're doing discovery is you want a complete kind of view of sources, right? The tool is written better, but the sources aren't the same. So if you look at the ReconNG/enum all tool that I put out the same year I did the last talk, and Sublister, the sources are a lot different. So you can see on the right-hand side, Sublister, or in the middle column, those are the ones that are covered by both. So scraping Google for subdomains, scraping Bing for subdomains, gathering from cert.sh, gathering from ThreatCrowd, and gathering from Netcraft. So it'll go out and take a top-level domain and look for subdomains off that top-level domain from all those sources. Now, independently, Sublister adds Baidu, Ask, DNS Dumpster, which is scans.io, VirusTotal, and PT Archive. And then independently, ReconNG can parse SSLtools.com, HackerTarget, and Shodan. And then there's a whole bunch of modules that aren't in the core, like ZoomEye, ThreatCrowd, to pull general zone transfer information back, the RiskIQ API if you have an API key for RiskIQ, and the census.io data. And all of these things are linked, by the way, in the end of the presentation. So you can get the slides, or you can Google these tools or whatever you want. But so there's just some overlap, but there's also some, if you exclusively go with one tool, there's some stuff you're missing. So as Tony Stark would say, is it too much to ask for both? And it's not. So Anshuman, who's in the Bug Hunter crowd, created a project called Brute Subs. Brute Subs is a set of Docker images that includes multiple tools. but the two being enum and sublister. And it'll start these up in independent Docker containers along with GoBuster and altDNS, which is part of enum. And it will basically run against a domain that you want. So you basically go pull this down, you Docker up compose, you have to set up a configuration file to say what your target is. And then if you want those not core recon ng modules, you have to modify the Docker scripts and you have to modify some of the config file. And then you also want to disable brute force for enum because that is slow. Don't do that. I made that tool. Don't brute force via enum. Not the best way to do that anymore. And I know Franz did a whole presentation about some of this stuff recently. I didn't know about it until very recently. Some of our stuff is very much the same, but hopefully you guys will learn anyway. So, all right. So there he is in chat. Good. So that is subdomain scraping in those two tool sets. Now there are some bespoke subdomain scraping things, two that I like. Haven't tested these yet, but I like the ideas behind them. So Cloudflare enum is the idea of scraping subdomains from Cloudflare, and census.py, which is also by Anshman, is in a get, which is a bespoke tool to scrape the census.io data. So you can see on the right hand side, this is the Cloudflare kind of deal. Hopefully these are easily portable into something like ReconNG or Sublister and putting that data in there. And if either of these tools has been updated in the last like week and has any of these modules, I apologize, but I'm pretty sure this is pretty recent. Anshman didn't realize I wrote that. Yeah, I mean, it's on your gist, man. I'm stalking you. All right, cool. So we talked about scraping and adding stuff to our scraping kind of arsenal. We can use brute subs to do both, or we can use brute subs to do both. So that's scraping. So now the next part is for discovery is subdomain brute forcing. And this is the idea of taking a word and adding it to your top level domain to check for a subdomain. So if I'm going after Coca-Cola.com, I'm going to check if their admin.coca-cola resolves. I'm going to check to see if qa.coca-cola resolves, right? And that was in the first presentation. We kind of showed how to do that. Well, I put out a couple tweets on subdomain brute forcing. Traditionally in pen testing, when I did this a lot, this is actually one of those things that takes a long time to do. And so I put out a tweet a while ago about what is this is a slow process. What are we doing? And so I got a lot of good feedback back, and some people yelled at me for not knowing about tools, and that's absolutely awesome. So what I did is some independent research on subdomain brute forcing tools. And so a lot of you use Subbrute or GoBuster, MassDNS, and then Black Sheep Wall. So these are the 5 kind of main tools I got back from feedback when I told people basically about DNS Parallel Prober. So I was really impressed by DNS Parallel Prober. It ran through a 1 million line subdomain dictionary in 42 minutes, which was to me pretty fast. And then a whole bunch of people were like, "You're an idiot, use GoBuster." And I was like, okay, so I'll try that. And then some other people were like, "Yeah, I heard of this thing called Masscan, it's pretty cool." So actually Masscan is awesome. So Masscan's technology, written in C, leverages Subbrute, but also the big thing that allows it to be so fast. Here you can see it did a 1 million line subdomain dictionary brute force in 1 minute 24 seconds. Basically distributes the resolvers, or distributes this work across multiple resolvers. So MassDNS will work the fastest. The problem is that not all the resolvers are reliable sometimes. Even when you use them in Subbrute, which MassDNS wraps around, you can see that the found domains are 213, right? So there were some false positives with that tool. GoBuster had more manageable output written in Go, and took 21 minutes to complete. So basically, I would use either one of these. I don't care because in my recon methodology, 213 gets pared down anyway later on when I do visual inspection of all the domains I find. And so I actually use Masscan just to save that 18 minutes or whatever. So, but both of those tools are awesome. You can see the infrastructure I ran these benchmarks against on the bottom. And so if you have any questions about this, trying to save you guys some time. So that's subdomain brute forcing. That list that you saw, all.txt, which is referenced in, you can see the exact command line runs I use there. That list is a combination of everything I could find, every DNS tool since like the dawn of DNS tools. I went out and conglomerated them into one master file sorted and unique. So this includes Bitquark's DNS research, which is really recent, the top 1 million popular subdomains, DNS Recon, Boluto, which is a blast from the past, Deep Magic, Reverse Raider, if any of you have heard of that one. I took all the Fierce lists, Knock, the Recon NG list, every subdomain rooting tool you've ever heard of got basically combined into all.txt. There's the gist for it. You can just grab it. And so with mass DNS, why don't we just do the whole list, right? Like, and also GoBuster. I mean, it's really a negligible impact. So what I also did here is I improved this a little bit also by taking the Raft top, where is it? Raft R. Yeah, the Raft lists, which are usually URL brute forcing or content discovery lists, and the top 1 million robots disallowed project, and those are two URL brute forcing, which we're going to talk about in a couple seconds, lists. I pruned them, I did some basically regex magics on them, and then I took those words and added them to this list as well. So this will hopefully take care of all of the word list needs. You can just grab that all.txt. It's huge, but with this, with this kind of tooling now, it's awesome. We can just run it quickly. All right, so we talked briefly in the last presentation about acquisitions, and we talked about using, what did we use? Wikipedia, and we used some other stuff as well. But really the end all be all for acquisitions, just for any kind of purpose, is Crunchbase. So Crunchbase, if you go to crunchbase.com, organization, the business name of the business you're attacking, and then acquisitions will give you a chronological list for all of their acquisitions, and those are linked, and then you can get to their websites, and those are top level domains you should then feed back into the beginning of your discovery loop. Now, these things have to be in scope. Please check to make sure they're in scope, but these are things that you should start doing. Now, Crunchbase itself, I would normally want like a command line tool so I could string this together with my normal discovery stuff. It's protected by distill bot protection, which means like normal methods on command line will not pull this page down. You'll get like a weird status error code. So working in Phantom.js right now to make a script to pull down this page. But definitely manually do this in the meantime, or if somebody beats me to it, write a script to parse the acquisitions from Crunchbase. And because Crunchbase gets used for like stock and like all kinds of other means, this is really well updated for any of these companies. All right, so the next section of discovery is port scanning. So we've started to pull in subdomains. We've started to maybe get an idea of an IP range from like an ASN for some of these targets. So I just took a target that I hack against normally, a really large target, a brand name, household brand name, and I searched their ASN, and the ranges gave me back about 65,000 hosts that maybe could be registered. So the thing I should do is port scan these. Now, as someone's saying, just do everything. Well, so what's on here is actually Nmap and masscan, right? So the last talk talked about Nmap, and Nmap is awesome, but if you try to scan 65,536 hosts with Nmap, with the default port list, it sucks. I mean, it takes forever. Like, it's just not going to work out for you unless you're waiting a really long time. Even if you tune the parallelism in Nmap, it still does not do the job I want. So masscan is kind of the tool for scanning the whole internet. The problem with masscan is it's written in C, it's super fast, that's not a problem. And it is super fast, you can thread it as much as you want, but the problem is it doesn't provide like a default port list. You have to specify every port. So this super long command line syntax here is actually the Nmap default ports list. So you could just copy this, and then they do take an input list for targets. So at this point, we pulled down a whole bunch of subdomains that maybe do or do not exist because we've scraped them off of places on the internet. We have a ASN range for our targets. We have a whole bunch of inputs, and then we can feed them all with this input list into masscan at the max rate of a lot of threads into a standard Nmap output. Yet that syntax does not work. -p through Oh yeah, I mean, you could do that for all ports. Yeah, this is just the default Nmap thing. So I'm not trying to scan all ports right here. I'm just trying to do the defaults of what I would normally get with Nmap. So time to run on this, 11 minutes, which is pretty darn good for 65,000 hosts. So do that, unless there's a faster way, and then tell me. Okay, so now I have a whole bunch of IPs. Really, I'm interested in scope that has web assets on it, unless it has like remote administration portals or something like that, or services that are in scope of the bug bounty. But at this point, I also have a lot of data that's been scraped off of the internet, right? Search engines and all of these data sources. So at this point, some of those could exist or could not exist, right? Because basically, they may have been taken off of line but been cached by Google. They may redirect to the main domain. They may be DNS redirects. So I need to get an idea visually of what I want to go after. So Eyewitness is a tool called, or Chris Trunter makes a tool called Eyewitness, and it helps me visually identify, after I have all of this data, what I actually want to go after. So I feed it the list output of my previous steps, and it will go take screenshots of all of those sites. And he actually built in a feature for me, because when I get the scraped data from Google or any of these other places, it doesn't include the protocol data. I don't know if these sites are HTTP or HTTPS, so it'll check both for every entry in my list and then take a screenshot and only provide me screenshots that actually like resolve for the web page. On top of this, it also checks for, just as part of the tool, it can check for RDP and VNC services running on these hosts, and it'll take a screenshot using libraries, so I actually see an RDP screenshot if services are found for this. So I really like Eyewitness. I know there's some other tools out there to do mass screenshotting of a list, but I think I like Eyewitness the most. So this gives me a good idea of what to go after. I'll just kind of, HTTP screenshot is another good one. I'm going to stick with Eyewitness for right now. So looking at the screenshots folder, I then can kind of visually identify what I want to hack. If I see admin portals here, if I see like QA portals or backend things that shouldn't be up, customer integrations or referrals pages, these are all things that are less tested than the main domain. So I want to go ahead and start looking at all this scope. All right, so the next step is, now that I have a whole bunch of websites I have found that exist that I want to hack, now I have to do some identification of the platform and see if there's any existing CVEs for these platforms. So in the previous version, we talked about retire.js, which will tell you out-of-date JavaScript frameworks that are running. And we talked about identifying with Wappalyzer and built with. And in the bottom left, you can see a screenshot is just like those buttons exist in your browser. You click them and it tells you what the server side is running, all the way down to like add an analytics frameworks. Built with is very verbose. Wappalyzer just keeps it on the web server and programming language level usually. So these tools I still use. They're great. They haven't changed at all since the last version of the talk. Now, something that has come up was in the last couple of days, the last week or something, is called Vulner Scanner. And Vulners is a site that basically conglomerates vulnerability data and CVE data and exploit data. Kind of like some of the old sites that have now gone offline. They've come up and started to be like one of those sites that will aggregate all that data and releases and CVE notices and exploits and stuff like that. So they created a burp extension. They'll basically go over domains that are inside of your scope, find the version numbers either through headers or other methods, and then depending on what the version number is, anything that's not up to that version number, it will give you links for vulnerabilities that are lower than that version number. And so you'll see in the end of kind of this workflow that you start getting a list of CVEs that might be associated to your target. So this is an easy way. You can also just Google, right? That's like the manual process that everybody does. But this uses a little bit. So in the right-hand side, you can see there's some CVE data. You can click on those right outside of burp and then kind of review vulnerabilities there. All right, so none of the rest of this presentation or the previous part of this presentation actually should replace walking and understanding the application. So when I give this presentation, people are like, oh, that's a lot of tooling and that's like script kiddie stuff. And I'm trying to give you the tooling to help automate some parts of the process and also give you an idea of like exploitation things and saving you time. But none of this should replace just general web hacking. In fact, I went to a talk last night by Mark Litchfield on input validation testing. And his talk is all about like bespoke input validation testing, putting things in boxes and parameters and changing get to post and putting negative values and like and actually understanding what the application is doing to a level where you might download a copy of the COTS software that is hosting your target and reversing that. And this doesn't replace any of that, right? This is just on top of it. Hosting your target and reversing that. And this doesn't replace any of it. So let's see here. Someone's got mic on, so there's a little bit of an echo. But okay, so now that we have we've done subdomain scraping, we've done some port scanning, we've done platform identification. Now that we have those sites, we also want to do content discovery or directory brute forcing. So content discovery and directory brute forcing are things like you used to hear about in books like Dirbuster, or you use WFuzz or Potador. But now GoBuster, since it's so fast and supports both DNS and URL discovery, is kind of my default tool to go here. We used a project called Robots Disallowed, which Daniel Miesler writes, and he went out and found the Alexa top whatever, I think, maybe million sites or 500,000, I don't know. He went up to an Alexa, parsed all of the top sites, then went out and spidered their robots.txt files, the stuff that they don't want you to spider or maybe see, and then he put them into a word list on Robots Disallowed. The same idea that Raft did a couple years ago, except for his project is updated. And so we can load those into GoBuster, and you can see here running that 119,000 word list against a domain. And let's see, the completion time looks like, one sec, doing it, 40 seconds. So pretty good. So 40 seconds or 40 minutes, yeah, either way, whatever. So GoBuster, super fast with content discovery and directory brute forcing. Burp had content discovery inside of Burp Pro re-upped like 6 months ago. It's really good. I just can't get on board, unfortunately, yet because it kind of bogs down the Java-ness of Burp for me. So 40 minutes to do that whole large word list. And so I just prefer to do it in a separate tool and then manually go back and add it into Burp when I find stuff. This also gives me a lot of options in GoBuster to filter by status code, pipe it in other command line tools, so your mileage may vary. You can also do this not with just directories that you're brute forcing with, but also scripts or files that may be left over that are like config files that you're looking for. Okay, so now I have unknown paths. I've done some content discovery. I've got a good list of apps that I'm looking at from all of my other discovery. What about the idea of that I find maybe a file or a script, but I have no idea what parameters to pass it, right? It's not COTS software. I can't figure out what parameters to pass this thing. I've tried all request methods. Can I brute force parameters? Absolutely, you can totally brute force parameters. So there's a tool called parameth by Mako, and basically what he'll do is he'll do some brute force on parameter names for certain scripts or paths. And so he actually has some heuristic learning logic inside of the tool for content size that's returned, for keywords and stuff like that inside of the script. And so it'll give you some idea of maybe I found a valid input vector for this script that I'm supposed to be sending data to. This can be combined with the list inside of /powered scanner for port trigger, which is the top 2,588 parameter names parsed off Alexa as well. So you can pair these two together to get some decent results. All right, so this is the whole thing kind of visualized. So this is kind of the discovery, I don't know, workflow I work in, and it's just me. I don't know if it's what you guys do, or like there's some discovery ninjas in the chat actually right now. So this is just me, but this is what I do. So identify IPs and main TLDs, usually from the bug bounty scope. Also look up the ASN for your target and reverse whoas information and acquisitions. Feed that into domain scraping for all that discovered stuff, using enumall or sublister, which can be combined using brute subs. That feeds into domain brute forcing, resolving everything. If you find new IP ranges, expanding upon those only if they're owned by your customer and adding them to your targets list. Mass DNS will help you here. You can also do this manually. Then port scan all of that stuff with mass scan with whatever port ranges you want. Then do some visual identification of everything to see what you want to hack with Eyewitness. Platform identification after that with built with and WAPalizer. Vulners is also something, the Vulners script we also talk about. Content discovery, GoBuster. I know a lot of people still love WFuzz and Potador to do that kind of tooling. And then with better word lists, and you could do it with Burp if you wanted to, and then parameter discovery. So this is kind of that whole workflow visualized. That's kind of what I do. So we will go through. All right, so the next section is cross-site scripting. So we talked about in the last section, we talked about polyglots, the idea of multi-context attack strings for forms or for parameters that would execute in multiple different contexts. So big long strings that would pop XSS no matter where it lands. We talked about sect lists and basically, you know, having an open source repository of fuzz strings that you can use in all your own tooling. If Dan's watching now, what's up, dude? We talked about some Flash reversing tools that were pretty cool to look for cross-site scripting in Flash. And then we talked about common input vectors. So common parameters or common input vectors where things were vulnerable to cross-site scripting across, you know, all of the kind of research that I did. So this time we're going to talk about blind XSS a lot, but there's not a lot in this section really. Cross-site scripting mostly stays the same. So right now, you know, a lot of people are adding to their methodology in the last couple of years blind XSS testing. And so it has to be included in scope, obviously. But blind XSS is an attack. We'll go on the next slide. But in order to facilitate your blind XSS testing, usually you want some sort of framework. And if you're not just doing one bespoke type of you know, contact form or input, you're actually trying to do blind XSS across a large domain, you probably are going to need a framework. So one of the first ones to come out was Sleepy Puppy by the Netflix security team. And so that one was a good one to start. So the one that seems like everybody is using, and in fact, I asked you guys about in the Bug Bounty Slack channel, you know, what you were using, Sleepy Puppy versus XSS Hunter. And a lot of you said XSS Hunter. So I did some research on like why that was, basically better payloads, and we'll talk about that right now. So Jobert actually made one called Ground Control, which is a more bespoke type, probably use case for this, but it's also small and can work for a lot of different things, not just blind XSS. It can also grab callbacks from SSRF and XSC vulnerabilities. And then we're also going to talk about like one new polyglot that came out, and then a pretty sick XSS resource called the XSS mind map. Okay, so blind XSS. Okay, so this is the idea of blind XSS if you've never heard of it. Franz goes to a site, he inputs this attack string, right? It goes through a series of tubes, and it goes to the back end of Jamie. Jamie is an admin, and he's monitoring this contact form or whatever it is, and he really enjoys having super admin access. He can do a lot of cool stuff from his backend portal. It's not the same web application. You know, the web application in stage one was you know, Franz didn't get any immediate cross-site scripting alerts with his regular cross-site scripting. In fact, it might be totally safe, but his input eventually ends up on Jamie's application in the backend. And so his cross-site scripting attack is referencing a JavaScript payload. So this JavaScript payload eventually makes its way to someone and executes somewhere, and it calls back. Now, so Franz needs one of these servers to catch it. And so the framework comes back to Franz's server, and Franz really enjoys his new super admin access he's borrowing from Jamie. So that's kind of the gist of blind XSS, if anyone hadn't heard of that before. Out of band XSS as well, it's called. Great. So this is XSS Hunter, and I did a little bit of research on why people like XSS Hunter versus Sleepy Puppy. So it falls mostly with the payload. So if you look at the tools as organizational frameworks, Netflix's Sleepy Puppy probably wins because it handles campaigns of blind SQL injection better. You can basically organize campaigns and stuff like that. But But XSS Hunter, which is also open source now, you don't have to sign up for it on the website anymore. It's open source, so you can host it yourself. Uh, it's got a pretty badass payload generation system, and it's open source, so it's pretty cool. So here's the idea, right? So the payload has options to parse a vulnerable page's URI, find the origin of execution, give you the IP address of where it's executing from, give you the refer, which gives you more information about the internal network and sites, gives you the victim's user agent, all non-HTTP only cookies, gives you the full DOM of the page, full screenshot of the page, which is super useful, and then gives you some HTTP request stuff. So this is the kind of stuff that you would see back in the old days when we weren't doing blind XSS, but we didn't know we weren't doing it, was the stuff with Beef and XSS Shell. And I would like to see some of those modules in Beef and XSS Shell in the pen testing kind of tools to get integrated into this payload and XSS Hunter, because I think that a marriage of all that kind of stuff would be super cool. But here is an example of the alert you get inside of this framework. It says, yo, somebody got hit with your payload. Here's a screenshot of their page, the victim's IP. You get an email. So if you're off having lunch, you're hacking while you're having lunch, and then you get an email report says someone executed a blind XSS attack. And then you can see there's a nice list. It's on mobile. That's the only screenshot I could find. But you have a list of every screenshot that's come through from your custom payload. So you have to register a domain and settle this stuff up. But once you do, super cool. Make sure this is in scope. There's a lot of discussion around whether blind XSS should be considered, in bug bounty scopes, right? Because you are sending data through the application that is in scope most of the time, but then it ends up on a completely different application. So is that in scope? I mean, you sent attack strings through a valid one. Did it? So this is a discussion that we're still having as an industry to figure out, like if blind XSS should be allowed. My personal opinion as a tester, I think it should. I think that the whole ecosystem of where data ends up should be thought about in this kind of thing, but not all people are ready for this, right? Like customer service agents aren't ready to get hit with cross-site scripting attacks, and internal applications are always less secure than on the internet applications. So make sure that your target is cool with this. All right, so we talked about XSS polyglots. We went over 3, I think, in the last version of the Bug Hunters methodology. So this is the one that came out right after, which was called Unleashing the Ultimate XSS Polyglot. The idea of a polyglot is an injection string that executes in multiple different contexts, as well as might be able to bypass certain filters, all with one string. So the cool thing about this is these things have actually started to be integrated into a lot of web scanners now, right? Like, because web scanners send bespoke attack strings to sites and then see how they respond with limited logic. And they actually caught on to this after the last presentation and started using these in their scanners because it saves them a lot of requests to do this type of testing for XSS and some other vulnerabilities as well. So this is the new one that came out. It's called the Ultimate XSS Polyglot. I actually find, honestly, that out of the 3 that I mentioned last time, I think it's a charge of VEDS that works for me the most often. Just no data behind that, but it's the one that works the most often for me. And then the CTF that they had for polyglots, how to execute in the most contexts. There's a couple on the top of that list, which is referenced in the previous presentation that I use a lot as well. So. All right, so this is really cool. I have actually used this a couple times to just reference. So if you're new to XSS, or you just like XSS, or you like organization, or you're OCD like me, Jack Massa is a researcher who came out with this XSS mind map that formerly used to be just in Japanese. And I saw it and I was like, this is awesome. This mind map breaks down attacks based on context, gives you proof of concepts for each one of those contexts, gives you ideas for info collection, for bespoke technologies, for file formats, everything that you could possibly, not possibly, but anything that you want to know about cross-site scripting. There's a chance it's referenced in here with an attack string and the context that you're putting into. It's a huge image file, huge. It gives you triggers and stuff like that. And so Previously only available in Japanese. He ported it recently to English. Now I can see all the right characters, at least most of the places, and I've used this a couple times to find cross-site scripting in certain contexts. So it is an SVG, yes. So all of these links will be in the presentation. And cool. So that's cross-site scripting section. So now we're going to talk about server-side request forgery. So this is one of those bugs that provides RCE most of the time. It only applies to applications that use a templating engine. So you can see some examples of templating engines on the right-hand side. How do you know if an application is using a templating engine? Well, Wapalyzer built with Vulnerscanner may be able to tell you if you know the application server and you've been playing with it for a while. You can tell if they're using a templating engine sometimes, but really some of the ways that you're going to find out are just test fuzzing this type of stuff. So you're going to have to send some like template injection, just basic strings to maybe see if something happens. So we'll go over that next slide. So we're going to talk about some tooling around this, and then we're going to talk about some other stuff. So some resources to go along with this. So this is the basic idea. This page uses a templating engine. It's associated to their error page here. And the like generic idea is we send some math inside of our mustache braces, and that will evaluate, hopefully, and we will know if we are using a templating system. And then in step 2, if we know we're using a template injection, I think this is Jinja or Flask. I probably should have put it in here what this is going as. I think it is Jinja or Flask. And then this is eventually, once I know that I'm attacking a templating engine to see if it's vulnerable and I can use read to pull out the Etsy password information, that's what the second attack is for. So what can you do here? What is like some automation to do this injection testing or something like that? If you don't know what subclasses to use to read or something like that, there's a pretty baller tool called TPL map. So TPL map is an automated kind of SQL map or comics specifically for template injection, and it covers a lot of the templating frameworks out there. Here you can see me running it against just a sample Flask application where I found a parameter called name. Immediately identifies that it's a vulnerable template injection just by using the injection of mustache braces and stars, and then you ask for an OS shell, which is kind of what you do. So just like SQL map or comics or anything that you've used, it gives me a mock shell and I cat out Etsy password. So if you want to get really in depth with SSI tool or SSI kind of methodology, you want to start looking at the source code of TPL map. It gives you a lot of information and injection strings for each one of the templating engines that it's attacking. So it's kind of where I learned to do this manually is by reverse engineering the tooling that they're doing here, or you could just use the tool if you wanted to. Cool, other SSTI resources. So I am not an expert in templating engines, but there's been a lot of research. These are the best resources I could find on template injection. The original white paper by James Kettle, then an OWASP workshop by Jerome. I don't know how to say that with the tildes and the up care, sorry. And then some articles on Flash Jinja, and then a couple of public disclosures of how this took place in either a CVE or on a HackerOne program. It's funny because if you look at this table, it's the same resources that Pete has in his book, Web Hacking -1. So I guess great minds think alike. I really love Pete's book, so I just gave him a little thought bubble right there. What's up, Pete? So these will kind of, as well as looking at the source code of that tool, give you a pretty solid foundation around what SSTI is, a lot of places that you can exploit it and stuff like that. All right, server-side request forgery. And this one's funny because I made all these backgrounds myself out of tools in my Kali boxes, and and I couldn't really find one for SSRF that looked like command liney. So this is actually Hacker Typer in the background. That's a lot of bullshit code in the background that doesn't do anything. Couldn't find a screenshot appropriate for the background of this one. So SSRF. So SSRF is the idea of, well, I'll go forward, is the idea of finding a parameter or path or post request that eventually takes a path of some sort. sometimes referencing to an external resource on the internet, sometimes referencing to an internal resource. So the top 4 things on the left-hand side would be examples of, things that you would look for where you would look for SSRF at. Now you can see like URL equals HTTP, URL equals // URL equals Google, URL equals path to something here, right? The idea with SSRF, and the reason I only cover it partially and where to look for it partially in this section is because looking for SSRF, at least to me, feels a lot like looking for LFI, RFI, path traversal, and directory traversal, which are all names for a lot of the things that are the same. So it's kind of a remix of that kind of testing, right? You're going to look for any path or any URL that's referenced in any type of request or response across, right? So what are some resources here? Because if you find a good SSRF bug, you can actually get RCE, P1 RCEs out of this kind of stuff. So some common parameters, this is from the old presentation. One of the things that you're going to realize is that some of these I didn't give parameter tables for where we find these things most often. And that's because my DEF CON talk is going to have a tool that alerts you of the common parameters where these vulnerabilities are found, and that'll be released in a week. So if you guys could just wait a week, you'll get all that data in a week. But we'll talk about some resources here in the SSRF world. So here's the idea at the bottom of now we're using a different URL handler. And we're able to do things like file : / etc password to return the data of the etc password, or TFTP. There's all kinds of protocol handlers you can use here. There's also some resources here that help you get around filters that are built for these parsers or the backends that are handling these paths, right? This is a presentation by Nicholas Roy. The idea behind this is that maybe they're filtering out like internal IP addresses. There's all kinds of ways to get around filtering that people do parsing on HTTP URLs or IPs, right? So the idea here is that, and this was like blew my mind. That's why I did the blew my mind GIF. Is that referencing an IP can be done in dotless decimal or dotless decimal overflow or dotted hexadecimal or dotless hexadecimal. Or dotted octal, and these will on some parsers still resolve, but are completely missed by a lot of filters. So what can you do with SSRF, and what kind of protocol and schema mappings can you use on different applications, right? So the SSRF Bible is kind of the default resource here for SSRF. Gives exploit examples for a lot of these things, but the tables are the most useful thing for a lot of people here. You can see that if you're attacking something, normally to do URL redirects or any kind of referencing, HTTP is going to be the URL schema that you're going to use, or that the application is actually going to use most of the time. But secondary, if you're trying to pull out files that are not part of the actual functionality of the app, you're going to want to use the one that has the most green across the deck, which is file or FTP. And so this paper has all of the URL schema support. It has examples for exfiltrating data using these schemas for a lot of different technologies as well. As you can see, the columns here are PHP, ASP.NET, Java, curl, etc. Whatever your target is. But there's a lot more data in this presentation, and this is a whole presentation in itself if you were to go over SSRF. Okay, so SSRF resources, basically there's a couple here. So pivoting from blind SSRF to RCE by Peter Adkins. There's one from Seth Art. That presentation called Server-Side Browsing Considered Harmful by Nicholas Grigori, I think. Jobert has a article on server-side request forgery. Zayat has a thing on it that he just published, and then Bishop Fox has a whole bunch of stuff on how to see this stuff when it comes back via Burp Collaborator. So a lot of the times these days, since you guys now have Collaborator, a lot of us didn't grow up with Collaborator, we'll see the Collaborator alerts in Burp. So Burp Collaborator will alert you and saying there's external service interaction, right? It's that it's either DNS or HTTP based, right? So the website, we fuzzed it with a path or a URL for Collaborator, and then it actually called out to us, and so we alert you of it in Burp. That's the idea. And so this kind of goes over how to use Burp Collaborator, then take it to a complete maybe exploit of SSRF. So pretty good article there. All right, so am I almost on time? Oh, that's not good. 11:15. I am almost out of time. Okay, let's try to go through some of this. Okay, so code injection, command injection, and kind of the future of fuzzing. So before we talked a lot about SQL injections, SQL injection polyglots, how to use your own fuzz lists and sec lists, SQL map and advanced usage, top parameters that were vulnerable to code injection, tooling, resources, etc. So for pivoting to code injection and then command injection as well as other fuzzing stuff, I have really been enjoying comics recently. So comics added support for code injection quite a while ago, but I don't see it talked about a lot. So PHP code injection is supported in comics. I used it on a pen test or a bug bounty recently, and it was able to find a method of code injection that I wasn't able to find manually, so super cool. And then unknown identification of injection vulnerabilities. I am really excited about / powered scanner, which is a new module to Burp. So let's talk about those. So this is comics. So the comics pros I really like for exploiting command injection are that it supports PHP code injection now. It also supports custom exploitation modules or just custom injection modules. So it couldn't just be for command injection. You can actually extend the framework to do anything you want. But on the kind of Metasploit vibe it gives off, where you can tell it to use your own shells, is actually really useful. So they're able to deliver back shells from command injection or code injection as a Python shell, as a PowerShell shell. There's a couple of versions of shells that you can actually return when you're doing data exfiltration through some of these things. There's multiple methods to get a shell if one doesn't work. And also they have some slides for comics, which I really enjoy because they've got a lot of memes, just like mine. So / powered scanner is part of a Burp project that Albino Wax is working on as well. It's the idea of going back to kind of our roots, where you just put in a tick and see what happens to the application manually. The problem is that doesn't scale across a large site and every goddamn parameter you have to test, right? So the idea of / powered scanner is to try to emulate that methodology, but in an automated way. And then tell you not that something's vulnerable, but that you need to go look at something. So it's the data-driven kind of thing that we're going to do with Hunt, where we give you parameters that are syntactically vulnerable, usually because people make parameters that do certain things, and we recognize that we should probably look at those. This is that idea, but using bespoke fuzzing tools as well, or bespoke and generic payloads as well. So like you can send a tick and get an error, and then you can escape your tick and not get an error. And doing some multi-tiered kind of effective response analyzing that's really good, / powered scanner will tell you that the response was different enough that you should go check it out. So you can see on the right-hand side, you can see a whole bunch of transformations, they call them, that mustache brace to actually convert it to mustache brace. And so these are all the ones that you should check out. So they might be indicative of code injection in some language. So there's a lot going on in this Burp plugin, and I'm really excited about it. I think this with Hunt is going to be probably the future of a lot of testing. So watch the video first, which is the first link, to get an overview of the tool, then read the white paper. And I don't know if a lot of people have been using this or not. It's been out for quite a while. I just think it's the bee's knees. And also I look up to the Burp guys a lot. So I think this is really cool. It's kind of the future of fuzzing, when we can get this down really well. Also his response analyzing is really good. It's different than a lot of scanners that use it around. And it's an effective way to go across a lot of parameters. When I listened to Mark's talk last night, he sits inside of every request. He just does everything manually, and that, he makes a lot of money doing bug hunting, and so there's a lot to be said for that. And I actually want to make myself better by doing that and just sitting in the data without using tooling. But I think this is a good idea to investigate this kind of route as well.
Hey, Jason, so we're coming up on your last minute, basically, before we got to switch over.
Okay. All right. Sorry, guys. All right. So command injection resources. These are what I would go read for learning about command injection, code injection, and some of that other stuff. Infrastructure and coding. I will blow through this. So basically, these services all usually connect to CNAMEs. And when one of these services has lapsed, you can register it yourself and control traffic that goes to your target if they've used any of these before. So that's the GIF from Zombieland, where Woody Harrelson is wiping his tears with money because money isn't worth anything anymore in a world that's overtaken by zombies. So now we have Franz just wiping his face with money. He's kind of the coiner of this vulnerability class, subdomain takeover. He does a lot of good writing about it, and his tool is really good at it. These are the services I see most often vulnerable to kind of the CNAME takeover, subdomain takeover kind of thing. So yeah. All right, subdomain takeover. So some tooling for this, just real quick: hostile sub brute forcer, TKO subs, and auto sub takeover. All I've had success with in the past. They all do different things. They'll explore CNAMEs, or they'll expose services that were connected to CNAMEs. These sections I didn't really get to investigate super hardcore. Franz just dropped an article on a deep dive into AWS S3 access controls and how to test AWS buckets. Peter has done a video about this, and there's some bespoke tooling called Sandcastle and Bucket Finder that are pretty old. I don't know if they still apply to some of this, but this is where a lot of people are getting P1s right now, is misconfigured shiz, both in the AWS world and in the Git world. So GitRob and TruffleHog are two tools here that I've been told I should have included, even though I know nothing about them. So check these out. In future versions, I will have like walkthroughs of kind of what these do, how they do it, if they're the best at what they do, etc. Bespoke info. I have a whole outline of my domain discovery talk at DEF CON Recon Village on Saturday. Hunt, the tool that we're going to give out at DEF CON, does the parameter discovery, and that will be out at DEF CON. We'll be giving that talk on Saturday as well. So come see our talks. We hope that this helped you. All of this will eventually get parsed into the bug hunters methodology on GitHub, my thing. It's ugly right now. Just give me some time to fix it. It'll be all added eventually. And the bug bounty forum, as well as the new one we launched today, they're great resources to talk with other people about methods, as well as read interviews from people and stuff like that. And I'm an admin on both of those. So these are all links just to thank everyone. And that's my contact information if you just want to reach out. So Haddix on Twitter, and then jhaddix@bugcrowd.com. Cool. I'm done, Sam.
Thanks, Jason. Everyone loved your presentation. People are clapping. You just can't hear it. Thanks, everyone. We'll put up this video, obviously, and we'll also have slides up as well. We'll work with Jason to get these resources out there. But thanks, everyone, for tuning in.